Hello everyone, welcome back. In this video, we will talk about different switches and how to interface a switch with our. So let's get started. In this slide, you can see there are different types of suites available in the market for using in your project. Like there is one type called SP. The full form is single pole. Single true, the switches are like this. Then we have SPDD single pole, double true. The switches are like this. We have DPST double pull, single troll, and DPDT double pull, double troll. These are different types of switch. Other than this, there is also a switch called deep type of switch, which has a rack-up switch, and you can use them in your different process for switching multiple loads or multiple components. In this video, we'll basically take this type of switch that is a push switch, and we'll try to understand how we can interface this type of switch with, so the internal structure push switch. It has 4 leg, the upper 2 leg, that is A and B. These are connected between themselves, and C and D are connected between themselves. So when we press this button, we'll make a contract between AB plate to CD plate. Otherwise, if you release the bottom, it will pop up and open the circuit. So this is basically a push switch. It will not keep stuck if you press this. As soon as you release the button, it will pop up and disconnect the connection. When we are dealing with this type of push switch, we need to use some specific configuration for to use this switch as I input. Here we can see 2 circuits. On the left-hand side, there's a circuit with a power source VCC. Then we have a Wisdom Sense series with a switch. And finally, ground above the switch. After the raised 10th, we have taken an output and fade the output to the, 2-number pin that is digital input pin. In a similar manner, on the right-hand side, we have the same circuit. But the difference is on the left-hand side, the circuit switch is open, and on the right-hand side, the circuit switch is closed. Now let me explain what is happening here. If we build a circuit like this, when the switch is turned off, that is, switch is open. Then our power supply, that is VC, a current will start flowing from VCC to race to the 2-number pin, which is a digital input pin for, the pin will read positive supply, and it will take it as a logical 1 or high input. So when the switch is open, the original will read high R1. On the right-hand side, the switch is closed for this case. And when the switch is closed, we can see the 2-number pin of, which is a digital input pin. It is directly connected to the ground, so it will read nothing. But 0 volt is leveled for this sort of configuration, as the ground is directly connected to 2-number pin. It will rate 0 low. So these are 2 configurations of original suite. Using this circuit and the racer we are using here, it is called the pull-up racer. Why? Because when the suite is open, it is keeping the digital input into as always high. So that is why it is called pull-up racer. If the restaurant was connected to ground, then it would have been a pull-down racer. Has a built-in pull-up and pull-down racer connected with this digital input pins. We'll see that later, but for now, we will try this circuit and try to see if the switch operation can be detected using, program. Before going ahead, I also want to introduce another concept related to switching that is called deep bouncing. So, what is the bouncing? When we press or release a button, it can create a phenomena called bounce, where the electrical connections momentarily makes our break several times. So this is a problem because we are pressing 1 time, but due to the transients or due to the bouncing, it will read multiple on and off. So we can deal with this sort of devouncing from hard apart. as well as from softer part if you want to use softer devancing method. Then adding a delay will be enough to reduce that effect if you want to solve devalsing using hardware. Then you can connect a capacitor. Across the switching terminal, it will remove the transient, or it will remove the devalsing. But for now, we will use the software delay. It will not show the capacitor method for handling divorcing for now. And another concept is related to push switch that we just mentioned. That is pull up and pull down race 2 concept. So Arduino board have built in pull up and pull down race 2. And to enable that pull down roster, we'll have to use the pin mode and an input pull up command. That is, the syntax will be pin mode within the bracket. We'll use pin then comma instead of input. We will have to use input pull up to enable the pull up register. So we'll see 2 demonstrations now. One without internal pull up. We will use external resistance as a pull up register. And then we'll use the internal pull up. We'll see both demonstration in the yoke. We will bring in. This is the first to build up the circuit we just saw. Then we'll bring in another racer. We'll connect the source with the racer. We'll use push button for switching element. Remember that the upper 2 leg, these are connected between themselves, and the lower tube, these are connected between themselves. So now from the second terminal, we will take our ground. And from the fast terminal, we can also take from here. We'll read the switch status. Let's move it a little bit. Okay. You could have brought this line from this pin. Also, it doesn't matter anyway. Now we have a VCC. We have a pull-up razor. And if we do not press this switch, this 2-number pin, it will rate the VCC and the razor. So it will rate a high voltage, that is 1. When you press this switch, the ground will be directly connected to this terminal. And it will read 0 volt. Let's see if we can program for this. So first of all, serial.begin. Then we will define using pin mode. Then, to number pin is our input. Then, serial.print. Industrial.print will first introduce a massive, and then will bring the switch value. That is digital grade. So it will read the status of the digital pin. And it will print side by side with this status. After that, for the next reading, we want to print a new line. Serial.print. And just bring a skip sequence for new line. And to deal with debouncing, we'll add a deal here. Delay of 100 milliseconds, so I think that's all. So let's see if we can read the push switcher status from this program. So, as we have mentioned earlier, the switch, I haven't pressed it here. That is why, and the pull-up racer is giving a high value here. And it is reading 1 once I press this switch. I have pressed this now and it is giving us 0 again. Once I release it, it will give us 1. So this is how we can program for our push. With using external pull-up register, and accordingly with this program, with this switch, you can also control LED like if you press the switch. LED connected to 30-number pin. It will turn on, and if you lose the switch, that means if you release the switch, it will turn off. Water treason will bring in the if-ill conditions. So here's the syntax and a structure for if-else condition. If you want to apply condition for any of your application, you can use EFLs or switches to pins. For EFLs, there are several structures available, like you can use if with elf. Or if you have multiple conditions, then you can use if-else, if-else. So how does this work after if in the fast bracket? We put a condition here if the condition is true. Or if the condition value is 1, then it will enter this bracket and execute whatever written in here. If the condition is not true, or if it is not 1, then it will come to this else bracket statements and execute this ones, so this is pretty simple for now. If and else is enough for the code you're looking for. In the upcoming video, maybe we'll try this structure, and then I will explain it in more details. Let's see. If our digital rate there is to pin, if digital rate's it is not pressed. Remember, if we do not press the switch, it will give 1. That is why the if condition statements will hold for not pressing the switch. So for that reason, we will turn up the LED digital write 13 pin dulo. And also need to introduce the pin 13 as output. 13 as output and else. Digital write 30, no, to I. So, with this block of if condition and else condition block, we can control the LED with the pressing of the switch. So let's see again. I haven't pressed the switch, so the LED is turned off if I press the switch. You can see that LED is turned on. Release it, it will turn off. Press it, it will turn on. So this is how we can use external cool operations with push to interface with I don't know now, the second down station, where we will reduce this razor and simplify the circuit using the internal pull-up razor. So let me delete this thing. SO in case of pull-up razor, the circuit will be like this. In the first button, I will connect to ground, and the second button, I will connect to 2 number pin. Now, if I do not press this switch, what will happen? No ground will be delivered to number pin. But due to internal pull-up, it will remain high. But once I press this switch, it will connect the ground to this pin. And ground will be supplied to pin no. Then it will read low. So if we do not press this switch, it will read high. If I press this switch, it will read low. Pretty simple, right? And we have also reduced the resistance. And we have losing another wiring to grow power supply. So use this sort of configuration. You just need to come here and change this input to input pull-up. So once you do this input pull-up, it will make the 2 number pin always high. And until and unless is a player ground. So let's see the same program will now work for similar functionalities we just had in our previous demonstration. See the LEDs turn off. The switch start is 1 because it is internally high. Now if I press this switch, the ground is supplied to P, no, 2. It will rate low and according to our program. The LED was on. Let me press it again. High LEDs, turn on. It is reading low, O. If I release it, it is ring 1 and LEDs turn on. So this is how we can use suite into using external pull-up resonance and using internal pull-up resonance. I hope this internal pull-up resonance is the simpler one, so we'll use it in our further programs. We will not increase the complexity of the circuit by introducing the resistance and additional ordering to power supply. We'll use this simple configuration with push switch. So that's all for this video. I hope you got the idea how to interface push switch. I don't know. See you in the next video. Thank you. Hello everyone, welcome back. This video is about audio interrupts. So what is interrupt? Interrupt is basically a mechanism that allows my to respond immediately to a specific event or condition without constantly checking for it. In the main program loop, there is a void loop. Interrupts are used for event-driven handling of external events, like button presses, sensor reading, or timer overflows. When an interrupt occurs, or when the specified event occurs, it triggers the associated interrupt service routine. So this is basically extra function in the program. It's a bunch of code where we define what should happen. When an interrupt triggers, I do not support different types of interrupts, like external interrupts, Pintinge's interrupt timer interrupts, and ISR, which is interrupt service routine. And it is basically a separate function you define in your Arduino kit, so whenever I enter this triggered, the program will jump into this ISR. It contains the code that you want to execute. When they interrupt, this trigger to enable or disable interrupt. We have functions from Arduino library. There is no interrupts in total for interrupt functions for Arduino interrupts. 2 is external interest, like at that interrupt. Detach interrupts if you are connecting any switch or any external signal to your Arduino. You need to do the configuration using this. At that interrupt for enabling the entrap and detach. Entrap to disable the entrap. And in the main function or in the main program, once you attach your interrupts in the configuration, in the main program, if you want to enable interrupt, this function is used for that. And for disabling, the interrupt this function is used. If you want to learn more on these functions and what are the same taxes, you can go to Arduino references from interrupt. Let's have a look. This is the paste from arduino.cc reference/in. From here, if you go down, you will find 2 sections, like external interrupts with 2 functions. At that interrupt and data center, and from interrupts, you have interrupts. No interrupts. These are the function we can use for working with interrupts. Let's take a look at the address, interrupt sent. Now, if you're using external interrupt and digital pins for interrupt, then you need to check out this table first. For Arduino, Uno, Nano Mini, and other 328 base, cheap, the digital pins is over interest are 2 and 3. So in the I don't know or no, you have digital pins from 0 to 13. Among them, you can use 2 and 3 for digital interrupts. Also, there's other boat here. You can check them out. Like many of us, we use Mega 25. 60 megaboat for larger projects. They have several pins for digital interrupts, like 2, 380, 1920, 21. You can check out this table. When you are working with interrupts, let us talk about the steps of using external interrupt SSD. We need to configure the hardware first and choose the external interrupt on our Arduino port. Like in the previous table we have seen, we can use 2 and 3 for Arduino. The available external interpons vary depending on the specific Arduino model. As shown in the table, common choices include pin 2 and 3 on mini Arduinobots, the second estate piece, connective sensor or signal source. In this case, we're using our digital suite. There is push suite for our interrupt triggering. So hence, we will connect the sensor or signal source to the choosing external interrupt. In our guess, we are using 2, and we need to ensure the signal source and the Arduino share a common ground for the reference, and that also has been done here. As we are taking ground in the suite itself. Party step 2, declare global variables. From here, the programming party steps. Now, the term global variables might be new to many learners. So, let me clear the fact first. What is global variable and local variable? There are 2 types of variable with our respect to the scope and execution. The first one is global variable. It is accessible from anywhere in the program. A lifetime exists throughout the program execution, and accessibility can be accessed from any part of the program, whereas local variable is limited to a specific function. While it is defined lifetime, it exists only while the function is executing, and accessibility only accessible within the function, where it is declared. Now here's the dummy program. On the right-hand side, you can see, as we use an arrow, this is the word setup for contribution and word loop. Our main program, we put it here. Now let's say we have used another function. That is quite some function. There's just sodominium within the function. we have initialized another video that is inked. Local v, and we are assigning a value of 5 to this variable. So this local v, this variable is only accessible within this scope, within this bracket, and within this scope of sound function. But we cannot access the local VAR from other functions, like void loop or vort setup. So this is the properties of local variable. Whereas the global variable, into global VAR, is equal to 10. This is one global variable example. This variable has been defined and outside any function. We can access this global variable from wide setup, or from wide look, or from this sum function. Also, this is the difference between global variable and local variable, and a brief local variable is only executable, only accessible at, only exists within a specific function. Out of that function, it is not known or it is not usable. Whereas a global variable, it can be used throughout the whole program. It can be accessed throughout the whole program, from any function, from any place. So that's the difference between global variable and local variable when we're using global interrupt. We need to define some variables like global variable so that we can access them from interrupt service. Routine or other functions is step 3. That is why we are using global variable. This is to define variables to our hold the pin number for external in trap and any other variable in it, in skit. Like you can use constant in to hold the pin number. We are using a variable interpin and volatile ain't interrupt counter for using a counter. We are using disorder variable. And these are defined and initialized outside telescope of any function at the top of the program, and it will be useful global variable. Now, here comes a stage 4. In stage 4 first, we need to configure the external interpin as an input. So using pin mode, we will define the interpin as input. Pull up, remember input pull up. We need to use it here. If you are using internal pull up, congregation for the switch. Next, we need to enable the specific external interrupt using @pat interrupt. So at us interrupt, this syntax is at us interrupt. After writing that digital pin to interrupt, you need to define the pin number here. Then ISR. You need to put your interrupt service routine function name here. Then comes the mode. For at a reinterrupt, we have 5 mood here. The first one is low, which means whenever the pin is low, it will interrupt the trigger. The second one is change whenever the pin changes value. Rising, it means whenever the pin goes from low to high, and falling whenever it goes too low from high. So any of this is available for our, I don't know. But if you're using dual 0-hour maker series mode, you can also use high as mode. Now comes the 5th stage. That is defining interrupt service shooting. In short, we need to create a function to be executed when the external interrupt is triggered. And this function is called interrupt service shooting. What we need to do within this function, inside the ISR or inter-service routine, we need to update some variables or perform some specific actions. Or we can also set flags based on the interrupt event. Like here at the right-hand side example, we have used a void handle interrupt. This is the name of the interpret service routine. Within the function, we are using a counter like interrupt counter plus. It is incriminating the value of the counter. And we are also using a delay, as we are using switch for external interrupt. With the switch to the effect might come at the external interrupt. So to handle that, we are using a delay here. Now, let's put together all the steps we have talked about and see if we can react them together. Let's far from the step 1 and step 2. That is related to the hardware setup. We'll first bring in a push button from here. And we will take up this bounce for now. Okay, so we'll be using internal pull-up, raise tense for using this push button as a suite. So that is why we'll connect this terminal 1. Terminal 2, pin to our external, enter pin 2. We can also use 3 here, both of them work. And from the above to pin. Any of the pin will connect it to ground. Let's make it black here, okay? So this switch, it will work as the source of our interrupt. The step 1 and step 2 is down here. Let's do the step 3. The strip 3 was declaring global variables. So let's do that as still. Here, we'll take one variable for defining the pin. For our interrupt, so that's why we'll take constant interrupt pin. And we are using 2, so that's why we'll put 2 here. We'll define another variable here for doing the count. How many times we are pressing, the switch will count that. So for that reason, we will use another variable. We can use volatile type and we are using the name as counter and initializing with the value of 0. So this will cover the step 3. Now comes the step 4. In step 4, we need to do 2 jobs. The first one is defining pin mode. So let's do pin mode. And we will put the interrupt pin as input. Pull up. And the second task is to define that interrupt for external interrupting. Let's do that at that interrupt. From here, the fast parameter it takes is digital pin to interrupt. Within the bracket, we'll put the interpin name. That is interpin for our case. The second parameter it takes is the ISR function name. So let's put a function here. Void and will use the function counter function. This is a RBJ name. You can make any name here. So this will go here. That is the counter function. Function name here. Then you can use any of the mode of interrupt. I am using the rising, so now comes the step 5. Defining the ISR function. In the ISR function, we want to count how many times the switch has been pressed, so it was initially said. At the first time the interrupt was triggered, it will come down here and it will implement the value of counter with 1. We can do that using counter plus plus. So counter plus plus is basically counter is equal to counter plus 1. So these are increment operator here. We are using and we want to use delay for handling the bouncing effect. So let's put 200 here. This will count how many times we have pressed the switch if you want to print that fellow at a serial screen. We can do that also. Let's initialize the serial print with 9600 baud rate and within the wide loop. Serial dot print switch pressed. These are masses you're putting here. Then serial dot print how many times which has been pressed. That is the counter, and for next line, we're using high skip sequence /n for new line. So this will be all for the program. Now let's see if our program works with our setup. So let's run the simulation Swiss paste 0 time. Let's press it once. It's pressed once, then 2, 3, 4, 5, and it's going smoothly. So that'll be all for this video. See you in the next video. Thanks.